Alright, students, we now have this action-packed, very juicy problem right here. This is highly intense, alright? So make sure you have your math shoes on, make sure you have your calculator in your hand, and let's go ahead and do this problem right here. Alex and Jake. If you're wondering where did I come up with these names, I used to have a dog named Alex, and I used to have a dog named Jake. They were both black labs. I love black labs. I currently have a black lab. His name is Frank. My parents have a black lab. His name's Otis. But anyways, Alex and Jake are named after my former black labs. All right. But anyways, we're going to pretend that they're students. So Alex and Jake are leaving Darby High School at the end of the day. Alex takes the red route home. On his way home, he stops at Wits. Ooh, I love Wits. I like to get caramel praline pecan Witzer to get ice cream, and Subway for dinner. Ooh, I love the oven roasted chicken on flatbread. Anyways, Jake takes the blue route home. He stops at Speedway for his Speedy Freeze. Delicious. And habaneros for dinner. I like the chicken burrito. That's what I get every single time. Anywho, who walks the furthest on his way home? So, for fun, we're going to do Alex first. This is going to be so much fun. We're going to do Alex first. All right, he takes the red route home. And just for fun, this is going to be super duper fun. We're going to do distance formula the whole time. We're going to practice those skills. All right, I know we could do the Pythagorean theorem shortcut, but practice doesn't make perfect. Perfect practice makes perfect. So we're going to perfectly practice the distance formula, nail it, get it down, and then on the blue route for Jake, we'll practice the Pythagorean theorem shortcut. Anywho, so let's just write the distance formula down again, store it in our long-term memory. I wonder if you guys are having nightmares about the distance formula yet. You might be waking up in a cold sweat, your heart beating, dreaming about the distance formula. All right, that's it right there. Again, order doesn't matter. It could be x sub 1 minus x sub 2, so on and so forth. Anyways, we got this point right here. They're both starting at Darby High School, and we listed that as 0, 0. So I'm going to call that x1, y1. And then that's going to be my x2, y2. All right, labeling my points. And then I'm going to call this the distance from Darby to Wits. dw is the square root. Well, x sub 2 was 2. X sub 1 was 0 squared plus 6 minus 0 squared. So I plug in the numbers, and actually the computations don't look overwhelmingly scary. So the distance from Darby to Wits is going to be the square root of 2 squared plus 6 squared. So it's going to give me the square root of 4 plus 36, or the square root of 40. And I'm going to keep it as the square root of 40 for now. I'll explain later. All right, now we're going to find the distance from Wits to Subway. So in this particular portion of the problem, well, I'm just going to call Subway x1, y1, and then we can still use Wits as x2, y2. So from Wits, so let's highlight square root of 40 before we move further. The distance from, let's do Wits to Subway, WS. And notice how I always try to keep my work fairly organized fairly well. I try to do that. I try to model it for you guys. You guys need to keep your work organized as well. It's going to help you eliminate silly mistakes. We already have the distance formula written at the top. So let's go ahead and just start plugging things in. Now it's going to be 2 minus 5 squared plus 6 minus 8 squared. So we're going to get negative 3 squared plus negative 2 squared, giant square root, 9 plus 4 square root of 13. Nice. All right, now you mons, we got to calculate this last distance right here. So we could technically use the distance formula, but that would be redonkulous. Let's just go ahead and count this. The distance from Subway to home is just 1, 2, 3, 4, 5. A distance of 5. We'll highlight that in pink as well. All right, so now the distance Alex traveled This is how it's going to look like if we use a traditional calculator. So if once we plug square roots into the calculator, that's not a perfect square, we're going to have to start rounding. So if I wait till the very end to plug everything in, I'm going to eliminate my rounding errors, and I'm going to have a more accurate number. That's why I kept it at the square root of 40, the square root of 13, so on and so forth. So Alex walks a distance of about 14.9. All right. All right. Now this is action-packed. Jake, we gotta find the length Jake walked. Is it further? Is it shorter? I'm gonna predict longer. Prediction, I'm not entirely sure. All right, so Jake, we're gonna do Jake down here, and we're gonna do the Pythagorean theorem shortcut. All right, so what I need to do is just make a series of right triangles. We're gonna just do it one at a time. We're gonna focus on this right triangle right here. All right, so we have C, this side's 8, this side's 1. Actually, we'll call this lowercase. We'll call this P for Speedway. You don't want to use S for Speedway because your S might look like a 5. If you ever noticed in math, they try to avoid using S as a variable because we're not very smart. We would confuse ourselves and think that S was a 5. So I'm going to use P for Speedway. Anywho, I get P squared equals 65. So I must take the square root of both sides. And then just like before, I'm going to leave P as the square root of 65 for now. I'm not entirely sure what that number is, but we're just going to keep it like that. Highlight it in orange, that looks good. Okay. Now, I must make another right triangle from Speedway to Habaneros. Remember, I probably could have put a box where the right angle is. This time we got 2, we got 4 right here, and I'll call this H for Habaneros. So now I have H squared equals 2 squared plus 4 squared. H squared equals 4 plus 16. H squared equals 20. Take the square root of both sides. And for now, I'm just going to leave H as the square root of 20. And then similarly as before, all the way to home, we'll call M home because I don't want to use, we already use H. O can look like a 0, so I'll use M for home. That's just 1, 2, 3. From Habaneros to home, it's 3. All right, so now we gotta bash this into our calculator. Oh my gosh, I'm panicking. What number is going to be bigger? What number will be a larger quantity? Let me go ahead and plug and see what happens. Drum roll, please. Oh, wow. I was right. 15.5. So Jake walked further. Okay, that's a great problem though. We used the distance formula, we used the Pythagorean theorem shortcut, we're practicing our skills, building upon them, repetition, so on and so forth. What I want you guys to do now is answer this question in Canvas. Looks like a lot of fun. I wish I could participate. Submit it. Make sure we're striving for perfection. All right, have a good rest of your day and let me know if you have any questions.